It says it's live. Is it live? What is the question? Okay. Here we go. I'm seeing myself. Cool. Alright, so I guess we're gonna get started here. So let's see. So this stream, basically, the idea is that there's this thing called Motion Canvas. And it seems cool. It's made by this guy who's artificial, I think is how you would pronounce that. Or artificial? Whatever. Doesn't matter how it's pronounced, but he made this thing to make his YouTube videos, and it's super cool, and I want to use it to make my YouTube videos. And basically what it is sort of a editor for making slick little explanation animation things. And it's kind of two parts. It's like a graphical editor, and it's also simultaneously code-based. So I'm gonna get started and see how it goes. So let's see. TypeScript, yada yada. Don't like it, but maybe that'll change after this. It's not a replacement for traditional video editing software. It's important to note. So let's quick start. So first thing, need npm. Now I don't have npm, but what I do have is NixOS, and NixOS will let me do something called NixShell, and I can set up a Nix shell specifically so I don't have to install npm on my whole computer, but I can install it in a singular area. So let me make a new directory called motion canvas learn. And let's see, I'm going to go into that, and I'm going to vim, I think it's shell, I don't think it matters. Nix.shell. No, shell.nix, that's what I want. Shell.nix, there we go. Can paste, whoops. Classic vim paste error. There we go. So, this, once I actually use it, is going to basically drop me into a shell with dependencies that are sort of locally installed rather than installed on my whole system. So right now, the dependency is Ruby 3.2, which is not what I need. What I need is, come over to the NixOS search, I need npm. And npm is part of the Node.js 21 NixOS package. So if I click on this and I say, let me have this, and let me come back here, and let me replace this Ruby with Node.js 21 here, and that should be all I need to do. Now I can nix shell into shell.nix. It's going to do its thing, and if I run npm now, there it is. So that will set me up for using this and also keep, my workspace clean, so I don't have to worry about having npm installed everywhere. It's just where I need it. So let's see. Let's come back here now. And maybe we can do some sort of a split screen here. That's probably going to be beneficial. So, okay. So we just do a little npm init here. Move that over to the side. And this is going to be called learn motion, or you know what? This one's going to be called test one. No, that's even worse. Example learning example. Got there in the end. Figured it out. Project path is learning example. using TypeScript, using video with FFmpeg. And there we go. So now I can CD into my learning example, and that's going to be followed along over here. I can npm install, and I don't really know the ins and outs of npm and all that, but it's something. And this seems to work, so I'll take it. Let's see, and it's doing yada yada. And there's 0 vulnerabilities, so that's cool. That's a little out of the ordinary for Node, in my opinion, but, you know, whatever. Alright, let's npm start this whole thing. So now, if we come over here, we should be looking at this. And if I can see the play button over here, and I hit play, well, look at that. It's a thing. It does a thing. So let's see. So now I need to actually be able to edit my code. So that's going to be the next step. Let's do a little VS Code pop-up. And file, open folder, come look through my stuff, and open that. And now if I pop this over, whoop. And, oh, yeah, I trust all of the authors, because the authors are me. And I trust myself at least a little bit. Okay, so where are we looking? So that's project. I guess we want, okay, so maybe this scene. This seems right. It's talking about a circle. I'm seeing a circle here. Oh, wait, I'm looking at the wrong thing. Ah, here we go. So apparently, for anyone who's interested, this color is called light sea green. Sure. Let's see, can we make it red? Look at that. Hot reloading. It's the future. Alright, so now we got a red moving ball, and I bet even a blue one. So, seems like I might already be an expert on this whole thing. Alright. Well, that's it. That's it moving. Let me see. I need to rearrange things a bit here, huh? Let's see if I can... Close enough, I think. Maybe I'll swap those. Take this one. Oh my god. Take this one and put it over here. Nope. Not like that. Okay, bear with me for just a moment. I need to get some kind of tiling editor going at some point here, but for now, this is what I have. Expand that just a little bit, and then take this one, and can I not shrinky dink it? Come on. Yeah, it's the corner I wanted. Okay. And now I've got this beautiful setup. So I can still come over here and say this is green now. And look at that. It's green now. Okay, so now I can try following along. So, let's start here. If I take this code, including the imports, come over here and paste it in. And this is looking very much like the example. Red on the left, or red on the left, yep, yellow on the right, back and forth and back and forth. And cool. So everything seems to be set up. So now I guess it's just the learning. Got some hex colors, got some positions. Cool. All right. Explanation. So yada yada. We have a project TS. I think I saw that over here. Yep. So this is our kind of our root here. This is where everything comes from. And we're importing make project, okay, importing example, and that's our specific code here. And then we're exporting default make project scenes example. Okay, I don't know anything about TSX. I don't know that much about TypeScript, so that all makes sense to me. insofar as it doesn't make no sense. Set of elements, split on screen, animation and government. Most basic scene looks like follows. Blah blah blah. Got that going. Let's see here. Okay, so that's all pretty straightforward. So you can learn about a scene, in the scene hierarchy section. For now, what's important is that in an example, you had a circle. Okay. Make it red. Set its width to yada yada and position to da da da. And we grab a reference to it. So we have to actually name our circle so that we can reference it. Logical. Fair enough. And that's the purpose of the create ref function. We use to create a reference and pass it to our circle using the ref. Okay. Oh wait, did I miss something up here? Is there a my circle I missed? Oh, there is a my circle I missed. Okay. It's feeling interesting to me, but okay. We are declaring the reference and then saying, okay, sure. Sure. Okay, well, okay, so now we have a reference. We put that in there. We then access it through my circle. Yeah, that makes sense. And this snippet is confusing. Okay. Fill and position, yada yada. So, using our function to retrieve the property's value. Cool. And then we can also update it. Cool. And then we can also update it with a transition time. Cool. So if we say fill and say 1, there you go. And that creates a tween. Got it. What's this going to tell us about? That just tells us about tweening. We'll learn more about that later, I'm sure. They don't play on their own. We need to tell them to. That's why they're declared using generators. They serve as a description of how the animations play out. By yielding, we can do different things. So we've got some kind of yield here. Well, let's take out this code because we're not even really discussing it. And let's try what they have here. Let's say we're going to yield star my circle dot fit. Oh. Circle, there you go, it's a function. So there we fill it and we say, let's just say a nice red color. FF 0000. And let's see what that looks like by itself. It's just red. Who could have seen that coming? If I give it a 1, it's still just red. Is there some way to like... Oh, okay, it's slightly less red and then it becomes more red. Cool. Maybe we should start the color somewhere a little different, like blue. There we go. And there you go. Nice purpley transition. Beautiful. So, cool. So and if we just did this, it would just say, oh, I guess there's nothing to animate. It goes from here to there. No time in between. So we have to put that in there and hit play, and then everything works as expected. Okay, and then if we want to do another one after, we do another yield. I can get behind that. I can understand that concept. So now we're going, okay, again, maybe not the greatest color for this since it's sort of close to red. Let's try a 0000 FF. Okay. I was trying to get to green, but I got to blue instead. There we go. So now we take a second to go from blue to red, take a second to go from red to green, and then it jumps back up to the top and starts over again. So, and we can write it in a more compact way, which is what the example was doing. So that makes sense. So instead of saying this one and then that one, we can say do this one or start at this one. That's interesting. 2 is an interesting description of that. Because I find it interesting. .2, and if we say our hashtag 00FF00 with a 1 second, this should look exactly the same. Yeah. Okay, cool. It's interesting. And I guess you can just keep chaining 2s, right? Yeah. And let's go back to our blue color. How about that? I'll just type in blue, just to be extra confusing. Because, yeah. Green, blue, red. Okay. And then it just transitions cyclically. Yeah. Okay. Alright. I guess 2 is a description of that. Goes from one to the other. Alright. Let's see. And now we're looking at... now we're back to like the example code. And now we're looking at the all. All takes one or more animations and merges them together. And so they happen at the same time. And there's some more information later. And that makes sense because if we tried to say... Let's do this. And I think... Well, let's see. I don't think this will work by itself because I think we need to yield it. Yeah. So... Oh, nope. That's the fill. I took the fill twice. But that's not what we want to do. We want to look at movement and then fill. Okay. So yeah, without yielding, nothing happens. If we then yield it, yield, I believe what'll happen is it'll move, staying blue, and then, so this is sequential. If we put them into this all with the yield at the top, like the example had from the beginning, then it says we have the movement, we have the color change, smush them together and do them at the same time, rather than movement and then color change. All right, I'm with it so far. Yeah, and that brings us back to our initial example, so maybe I'll just copy this and just replace everything, and there we are. Right back where we started. Trouble, I don't know this word. There we go. Okay. Let's take a look at some animation flow. Uses generator functions to describe animations. Function that can return multiple values, blah, blah, blah. So this example will yield 1, 2, and 3. Okay. Okay, that kind of generator. I see. So this is in like, yeah. I think those are in Python and stuff too, right? Yeah. It's a pattern I've seen before. So basically you can, like, imagine if here, instead of saying yield 1, 2, 3 specific numbers, it was like a loop that like adds 2 every time. And so every time you query it, it gives you another additional 2. That's a terrible explanation of what I was trying to say, but that's what you get to deal with. Okay, so when its yield keyword is countered, the execution of the function pauses and resumes only when the caller requests another value. This is particularly useful in declaring animations, blah, 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 change text, movement, the illusion of movement. We also want to commit a constant amount of time between these updates, so we can update things in between the yield keywords and then wait for whatever function yields. This is fundamentally the motion canvas. Yield means the current frame is ready, display it on the screen, and come back to me later. Okay. So, let's see. So we can flicker something on screen. What an idea. And the example from their code just doesn't work? I can't believe that. Do they not have I guess they don't have their imports? Which seems weird for the example, but if we do, okay. Yeesh. Okay, cool. So yeah, we can give ourselves seizures. That's a plus, I guess. I don't know in what column that's a plus, but it's a plus somewhere, I'm sure. Okay, so needless to say, we try to write all the animations for that. Fortunately, JavaScript has another keyword for use within generators, yield star. It allows us to delegate the yielding to another generator. Sure. We could extract flickering code from the... Okay. So instead of manually giving us our seizures, we can create a seizure procedure and then have that take care of itself. So that's good. Efficiency in all things, apparently. Okay, this is so weird. They have, because if I try to run this, right, that's not gonna work because they put some imports, but not all of the ones you need, which is strange to me. I don't know why. Maybe so you don't give yourself a seizure. There's an idea. The resulting animation is exactly the same, but now it's reusable. Awesome. Be like that one Pokemon episode that gave all those kids seizures that one time. Efficiently. Motion canvas, a lot of useful generators like this. You may remember this from 10 whole seconds ago. I do. I do remember doing that. It animates from ba-da-ba to ba-da-ba. Or no, from its current value to ba-da-ba. Right. I'll call it tweens because they animate between. So clever. Two values. You can learn more about them in the tweening section. Okay. Another kind of generators are flow generators. They take one or more generators input and combine them together. Mention blah, 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 blah. Okay, so the all is the one where you take the one, you take the other. Instead of doing them one after the other, you smush them together, send them at the same time. That's what we're looking at here. Okay, there's also apparently an any. So I guess that means, well, let's see. Let's see what that means. What's an any look like? An any looks like, I guess, we probably have to, import something else. Okay. An any doesn't look different for us, but I'm going to bet that based on what this is saying, if I set 1 to 0.5, ooh, did you see that? Ooh. Yeah, let's see. I think it might be more visually apparent if I set this to like 0.25. Ah, there you go. So, the any, as opposed to the all, is basically saying whichever one finishes first, everything's done. I don't care. Whereas if we turn this back to an all, it says, it lets the red finishes as it's moving back, and then it just kind of stays instead of, so it waits for everything to finish instead of just the first one, which is cool. Let's see, the next one we got is a chain. I'm gonna bet, I haven't read this yet, I promise. You're gonna take one, let it finish, and then do the next one. You're not gonna do anything unless you import everything under the sun. So, whew, that's an error message right there. Yes, and that is, so if you imagine all these things as like parallel processes, all doesn't really smush them together per se. It sends them both off, and then provided like one gets there first, it waits for the second one to catch up, and then they both come back. Any sends them both off. One gets there first, and it doesn't matter where the other one is. They both get sent back to the beginning. Chain sends one off, and then when it gets to the end, it sends the other one off, and then they come back. What else do we have? Okay, we have delay. Runs the generator callback after a specific amount of time. Well, this one seems intriguing. What does that mean? Like, okay. Oh, I didn't provide it with a time, I guess. Let's say 1 second. And hit play. Okay, very interesting to keep this in the same place as the other ones, because if we look, for whatever reason, the other ones operate on a series of things, on a array of things. This one decided, no, I'm not going to do that. I'm going to do just one. So, there you go. So it just does whatever's in there, but after a second. I guess that's useful. Seems like there's better ways to do delays than that, but maybe it comes in somewhere that I'm not expecting. Okay, last one here is a sequence, and we're of course jumping out of order and just going back to doing things in arrays. So let's sequence, huh? Bring this guy back, deal with our error, and sequence these. And this one, I'm betting I don't know. Let's see. Start one task after another. With a constant delay. Okay, so difference between this one and chain is chain. They're right here. This one gets to the end, then this one goes. They both come back. Delay seems to say, okay, send this one, and then a second later, this one can start. And then when this one gets to the end, it comes back, and then this one comes back. Or at least that's what seems to be happening, right? Yeah. So it lets this one get to the end. Oh, and then, okay. So it lets this one get to the end, and then this one comes in, and then they both come back. Okay. All right. Cool. Sequencing. Oh, and then even one more. A loop. And again, well, but this one's entirely different, it seems to be. Because the rest of these have been looking at tasks. Yeah. And then this one just throws that all out the window and says we're doing something different. Loop. Alright. And let's see where I just put loop in here. What's it going to do? Okay, this requires a yada yada. Doesn't like it. Can I do that? No, because this one just wants entirely different stuff. A new generator is created on each iteration. Factory loop callback. Okay, well, I don't know how to use this one because it's, let's see, example. Loop colors.length. Okay. I mean, sure, it's just so different than the rest of them that I question the wisdom of putting it with the rest of them. Because you're going to get there and be like, oh, it doesn't work. But I guess they all do animation flow. So where else are you going to put it? Sure. All right, well, let's see. Let's take these colors. Let's loop through these colors. Or not even, just loop colors dot length number of times. Okay. And then we're gonna get, okay, and then we're gonna do a callback, like a function right here, and just say my circle dot fill on colors that I, and do it for 2, and then not a, okay. I mean, that's working, so I guess yes, but strange, in my opinion. Can I do, if I don't do the length and I just loop through the, not assignable number. Well, can't JavaScript loop through non-numerical items? Am I crazy? No, evidently it can't. Okay, so you can only loop for numbers. You can't loop for items. Yeah, it says that right there. I guess I could read if I wanted to. A function, because generators can't be reset and generators created on each iteration. Sure. New iterators. Okay, I don't think that matters. Okay, and now for something completely different. These seem to be some. Okay, cool. There we go. These seem to be some dancing squares. They go down, and they come up, and they start over. Fancy, fancy. Let's see what we're learning here. So we're using array.map and all. Okay. Yield all rex dot map. Okay. Things are happening here. Okay, so something interesting here. We're making our references dynamically this time, because before, if you will recall, we just created one reference, but with create ref and not make ref. So they're just changing it all up. And I guess it looks like make ref here is for arrays. I don't know if they'll explain that anywhere. Nope, they just skip over that part. I'm sure it comes later. I guess this is a quick start after all. Okay. So regardless, we make an array. We make a ref for each one, going through a loop, toss them all in, and then wait for one, which again makes me question a delay. But hey, that's just me. Oh, I guess this one, whatever. I think that one probably you could start it and then the next one would start at the same time, whereas this one, everything after it has to wait. I'm assuming that's the difference there. Okay. And now we're doing it all again. Cool. And I'm wondering if it's some kind of TypeScript thing that I don't know. Let's see. Type. TSX. No, I don't care about the Canadian stock market, actually. TypeScript. Okay. Doesn't really matter. I'll learn more about that later. But it looks like... Go through all the rect and map. And cool. And most allocate ways to use multiple tweens. But it requires nesting all to do multiple tweens. No yield. We return this generator and deal with it outside. Okay. So it's basically just doing an all. But instead of... Where is it? Instead of laying these out one after the other, we can just loop through and create all those, and then that all gets sent to the all at once. Okay. That's clearish. Okay, we can also do the generators, and then the same thing, but just make it in a list instead, and then pass it in. Sure. Using a for loop is a cumbersome option because you have to figure out how long it takes generator loop to make it complete, but it's useful in some situations. Okay, so this one's the most manual, where we just, let's see. Let me take this and replace that. Okay, and everything works as expected. And I'm assuming if we don't wait, yeah, it just jumps to the end. Just jumps to the end. Yep. Because this yield star doesn't, well, the regular yield without the star, it doesn't actually wait for the thing. It just says, if I get queried, I'll return some information, but yield star actually waits for the thing. So now it's going to do this. And I think this would be the same, well, not quite the same. It's similar to this sequence, except it, yeah, it's similar to this sequence. It just doesn't, the delay is the maximum, basically. Which makes sense, I think. Okay. So that, where did this page? Way to go, Akshat Giri. Big thumbs up. Big thumbs up. Okay, let's look at a scene hierarchy. Scenes are collections of nodes displayed in your animation. Clear enough. They're organized in a tree hierarchy with the scene view at its root. This concept is similar to the document object model. Gross. Used to present HTML and XML documents. Gross. Okay, but here's an example of a simple scene hierarchy together with its object representations. a circle, a layout, a rect, a text, and a layout. Oh, and this is just like open close, like there's nothing inside the rect, it's just a rect. It's just a rect. So the scene view has a circle and a layout, and this layout has a rect and a high. Okay. Each node is an instance of a class extending the base node class to make the node code more readable. Motion Canvas uses a custom JSX runtime. Cool for them. Sway instead of XML like markup. Motion precision. Not use React to shelf. Only JSX. Blah 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 blah. I don't care. I don't want to know anything about Node or JSX. I just want to know about this. Okay, so if we didn't have JSX, we'd have to do this, which is not that bad. I mean, obviously this is nicer and cleaner and faster and better. But, Okay. Let's modify the hierarchy. There's a joke there that I can't find, but I swear it would have been funny. No class contains the children and parent properties that can be used to traverse the tree, but in order to modify it, it's recommended to use the following helper methods. No class contains the children and the parent. Okay. So we can look at children, we can look at parents. I'm guessing we can like manually put things where they need to be, but that's not recommended. So we have node add. Let's take a look here. So if we have a constant node that is a layout, we can add a rect and a circle. Cool. What happens if we do that? Let's see. I want to do this right here. Do we not know circle anymore? No, we've forgotten circle. And we never knew layout, but here we go. Okay. And now if we add, instead of all this fun stuff, we just add our node, we don't see anything, which is cool. Guessing it's because the circle is not really, like, defined. Here, let me take this rect and replace this rect. It's all mad at me. And just remove those. But we don't want make ref anymore because we want to create ref. Right? Oh, what was the... Let's see. Create ref. What? Going back real quick. Hold on. Going back again because it's all the way back here. Create ref. Right. Rect. Can we do that in here? Oh, we forgot to create ref. Of course. Let me see. Create ref. Comma. We're just still not happy. Oh, I know why. Because I want to put the layout in here. Look at that. We're back to something. Is the something anything? No. So scary every time. Okay, so rect, and I guess we'll have to see later why we don't see anything, but we don't, which is super strange to me. Because we add the rect. Okay, well, I guess I don't even know what a layout is yet. Jumping ahead of myself. But I had hoped. Okay, so we can add a node. We can insert a node, which is different than adding one because it's different than adding one. Oh, because we can give it an index. Got it. Let's see here. So that's the insert. If we do a remove, that's just removing a node from a tree. Okay, I can get behind that. Reparent changes the parent, sure. Let's see. Hold on. I'm trying to do two things at once. Surprisingly difficult. Incredible. Hold on. Okay. There we go. Oh, excuse that. Okay, we're gonna reparent. That's a reparent. Move up. Moves it up and siblings. And then we'll be right on top of it. Okay, sure. Move up, move down. I'd love to see some pictures like these. That'd be helpful. I'm assuming that means, like, in this example, if we did a move up, it would move it up to here, and then rect would point to layout, would point to text high, but they didn't provide a picture, so who knows. Move it down to its siblings. It'll go down right below it, and then we'll be rendered underneath it. Move it to the top. Place at the end of the children list and from there. Okay. Move to bottom. Move to, these are just moving around. Moving left, moving right, moving above, moving below. All makes sense. Alright, now here finally is a layout. Find all is text. What? Okay. Okay, I see what we're working with here. So why does my current layout not work? I have a layout, I have a circle. Do I need to align item center? Is that what I'm missing here? No. Because I'm doing a view.ab with the layout. Yeah. And the rect. What happens if I remove this circle? Anything? No. Why am I not seeing anything? That's... Oh, I know why. Because I'm in the layout. That's not what I need. I need a node. There we go. Okay, and the circle is basically undefined, so nothing shows up there. Let's just give it a quick width? Question mark? But not question mark? The width is 10. And the height? Again, not a question. Oh, well, okay. Just a little shorthand there for you. And it's got a width, and it's got a height, and it's got a fill, I guess? That's red. When is it gonna show? Ooh, there it is. Oh, he's so tiny. 100. There we go. 1,000 even. Oof. Whoa. That's one heck of a circle. Okay, and because of how the whole hierarchical nature of the whole thing, but I bet, looking at all these things, if I said no, nope, not node. Well, now I don't really have a reference to this rectangle because if I say const rect is equal to all of this, instead, I'm sure there's a way, well, I know there's a way, like this find all and whatever, but I want a reference to it, and then I want to say node dot add my rect. And okay, so we're not going to see anything, but now if I take the rect and I say move up, right? No, not right. Move to top. Let's try that. Yeah, look at that. So that took the rectangle, and it said, let's put it up. So this is all like Z layering, because, you know, if you have two-dimensional things, they're technically on the same plane, but you can sort of define which one's on top of the other. And they're just in the order that they're, I guess from this picture we could say they're sort of left to right. Yeah, so like left to right. This being on the bottom and this being on the top. At least that's how I'm assuming this is working without too much more information. If I do this, it goes away. If I take this and I put it down there, it comes back because it's on top. Okay, so that's all cool. Now there's this really cool Hitchhiker's Guide to the Galaxy 42 reference, which I love. And it's doing text. The text is changing color. I barely could tell. Maybe a more intense change would be better there, but alright. 42. Hilarious. Okay. It contains multiple text nodes. Right. So we're doing the find all because clearing the hierarchy, yada yada. We're doing a find all because if we just said one of these texts, it would be example or 42 or the question marks because those are all separate ideas. But when we do find all, we're getting a reference to all of them, and then we can do the whole from the last. It's all building on top of each other. From the last one, we take this, we map, we do da 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 da. All right. So to achieve that, we use find all text to search through. The first argument is the predicate. Okay. Oh, I see. The is. The is the predicate because we're not just finding all text. We're finding all is text. Let's see. Is there like view.find all is not? No. Is, what other is's do we have? Is type? Yeah, right. Maybe they'll explain some more of them to us later, but so far that seems weird. Oh, I guess you could probably say like, I don't even know. Like, is it okay? Whatever. We'll look more, but yeah, it's more than just it's more complicated. The return true if the no matches. Okay, I'm assuming it's like you're gonna do like a I and then one of these and say I dot type. Or maybe it's not one of those. I don't know. We'll have to see more about later about how we make those predicate functions. Let me see. Is X. Can I just... Can't even find an is. I'm sure it's up here somewhere. Is it in the core? Is. No. Is it in the 2D? Seems like it might be. Is with something. Yeah. Okay. So yeah, so you make a function. Okay, this is getting so far into the weeds that it's not even important. But the important thing is that there is an is. And there is not and is not. And that's all pretty clear. We could try... Okay, literally read 2 more steps ahead. Maybe. This is what I was trying to do. I don't know why it didn't work. I said like I and then I.scale.x is greater than 1. Okay, I guess it just didn't do some nice linting for me, which is fine. And node's already a ticket name, so no. And I could say no dot. Yeah, I guess it can't know. Can't know no. Whatever. So basically, yeah, it is one of these. It's a sort of a lambda-ish function where, and you can say an instance, and is just basically the nice way of doing this faster. Okay. These can be used in JavaScript. The final method has been implemented to traverse all descendants of a node, but if we want to create only the direct children, we could retrieve the children array and call filter. Okay. So right now, looking at this is inside of this is inside of this, so we're going all the way down the tree. But if we wanted to look at like just the children of the layout, which would exclude these two, we would say get the children and then filter on his text. Alright, fine. Okay, so we have find all, which is what we just looked at. Cool. Find first. That's a good one. Let's see, let me copy this example real quick. Alright, love that dark text. Now I did mess with this a little bit earlier, and I know I can do an RGB of a 255, 255, 255. Ooh, I thought I knew I could do that. RGB 1. I swear I did this earlier. RGB 1, 1, 1. There we go. I don't know why that didn't work a second ago, but there we go. So now we have our example 42. Let me zoom in a little bit. Hit play, and our color should change. Now, if instead of finding all, we say we want to find first. I'm going to imagine everything breaks. Because this was designed to operate on a array of values, several different values, whereas now we are just yield-alling, not even yield-alling, just yielding on texts. So I'm not going to change the name. And just do this and paste that in there, and I am changing that name, and I'm putting a semicolon where it's supposed to be, and I'm being confused. Okay, so now we're doing a find first, which only grabs the first one from our hierarchy. Makes a lot of sense. And I can't imagine what find last will do. That's insane. Found the last one. And find ancestor, that's a Disney movie. Find the closest ancestor of this node that matches the given predicate. Okay. That is oddly specific, but I'm sure is useful. Positioning. Alright. Yep. We're graphing. We're using a Cartesian coordinate system as opposed to polar. Its origin is located in the center of the scene with the x-axis going to the right and the y-axis going down. Cool. X-axis, y-axis. Nah, never mind, I don't care. Thought I was going to do it in place, but it does not. So, we can change the position. So we're looking at transforms now. Cool. Change position. Didn't mean to click on that. We can change scale. We can change rotation. And these are relative to the parent. Makes sense. So, like, let's say this 42, which I think let's do a little test here. If we say ref is equal to megaDoRef, yeah, megaDoRef of the text. But of course, doing it in here helps us in no way, shape, or form, because that ref is just in here now. Expected 2 arguments, got 1. I don't know about that. Let's try instead saying const text ref is equal to that. Why do you need, oh, well, you need this, txt ref. What if I do like a rect? Expected 2 arguments but got 1. What did I forget about make ref? Isn't that all it took before? Well, now I gotta go. Oh, shouldn't have clicked that button. Oh well. Not make ref, create, because make ref's for the arrays. Duh. Alright, let's get back to, can I just click here? No. Can I just click here? Okay. So now we're back to positioning. So not make ref. Thank you so much. Create ref. Red ref. Okay. So now we have created a ref to our text. And now out here, because this isn't a first or a last, I'm sure there was some other way to do it, but we can now say txt ref. Autocomplete. It's a nightmare. txt ref dot scale. Well, maybe I'm wrong about this. Let's find out. Vector 2 signal node. Oof. Scale does not exist on type reference text. Okay. Well, aren't we learning? Let const text node. Okay, so now we're doing things a little different here. So for some reason, whoa, nope, and there we go. What am I, Rustin? There we go. Okay, if we save this, it's all good, except the ooh, look at that, it automatically, because it's a child of the rect, and the rect has padding and a gap. Interesting. Okay, well that's cool. I do still want it there, though, so let me put the text node back. Just when I thought I had it. Do I have to put it in brackets? Nope. What's your problem? I don't know what that means. Okay. Well, that seems like it should work, but then it doesn't. And that's unfortunate. How strange. Why doesn't that work? If I take everything else out, does it work? Yes. But then when I bring the rest of it back, it doesn't. Do I need to put a comma here and a comma there? And no comma? Well, that's really interesting. So I guess you can't just throw that in there. Alright. Well, let's try a different tact on this, and this is all sort of a waste of time, but the ref is txt. Is it going to let me do that? No. Can I give it a name? Yeah, tag name. There we go. Okay, and then instead of find last, we're just going to find... Whoa. Find doesn't exist. Whew. This is giving me a run for my money. Let's just do find first, because we know that exists. And it's not as text. It's node. And we look at the node dot tag name. equals equals txt. And we're not happy. Why are we not happy? Does it need to be not? What is happening? So we can't give it a tag name. That's so weird. Some of this is very confusing to me, but I guess that's why we're learning. I guess is maybe they're like node dot content. No. Alright. Well, never mind. I was going to try to do some fun stuff with positioning and all that stuff, but maybe not. Maybe this was a waste of time, and I don't actually even need the one in the middle. I can just take... Come on, I can get back there. Alright. All good. Let's just take our text find last and just say text dot scale and say vector 2 1 comma 1. Oh boy, now we got to figure out how to construct a vector 2, which I guess is with a dot new. No. Vector 2 signal. What are you talking about? Okay, so what the heck is a vector 2 signal? You know what I bet's going to happen down here? A little bit further? No, this is absolute position. There's really no examples. Oh, here we go. Example for scaling. Okay. Alright, so we can scale it with like 1 comma 2 like that. Okay. Maybe. Yeah, no, that's a scale doubled in one direction and not in the other. Let's do it over 1 second. Does that still work? No. It doesn't. Oh, well, duh, of course it doesn't. Because we need to yield star the text. There we go. And it does, and it does. Alright. Alright. I'm still not sure how I'm supposed to get like a reference to this text out of the middle. That's the thing I'm hung up on, but whatever. We're creating a ref with the nodes. Ah, well, it was right down here the whole time. That's what my problem was. Is I'm not creating a reference to the text. I'm creating a reference to the node, the text node. How about that? So now if I say here ref is equal to the text ref, now I can say text is the text ref. Except incredibly I still can't. Is it because it's const and this needs to be var? Is it because I don't have something called text ref? I have something called txt ref? Does not exist for the reference of the node? Oh man. They don't want to make this easy for me. Weird. So a reference of a node is different from a node. Can't fault them on that. But also don't have to like it. Caller. Yeah? Is that's okay? Maybe? It's It's not working, so I don't think it's okay. But nothing. Oh, something's yelling at me. Here we go. Yeah. Okay, so don't do that. That's what that seems to say. Interesting. What else is in my text ref? The symbol? Why are you doing that? Okay, not the symbol. The bind. No. The call. Oh. Well, it says no, but it does do it. Calls a method of an object. Substituting another. Okay, I feel like this is probably not how it's supposed to work, but it does still. It sounds like JavaScript to me. Alright, well that worked, even though it's telling me it didn't. Very interesting. But anyways, got a ref to the middle one and was able to do stuff with it. And I'm gonna just for fun do text dot. Ooh, but it doesn't like it. Yeah, nothing's happy here. Position, scale. I'm gonna do it anyways. I'm gonna make it rotate. Text dot rotation. And of course, it's a different thing without an example. It's a simple signal. Which, who knows what that means? Can I just type a number? 10. I can. I can just type a number. So I'll take it. Although, that's invalid value yielded by the scene. Whew. Okay. So it sort of works. It doesn't yield now. Nah. Again, off in the weeds. Unnecessarily. Okay. And if I tried to yield star text dot rotation 100. Oh, forgot to put the 1 in there. Yeah, so that thing, other thing, probably would have worked. Not gonna go back for it right now, but that's interesting. We absolute the absolute position and assign it. Okay, see, but now create ref, do the thing. Okay. So instead of saying dot call, if we had said txt ref like that. No? No, that didn't work either. Ah, again, because this needs to be more. Yes. I'm getting weird errors, but it does work. Look at that. We're rotating to 42 again. Okay. Don't know why. Did we have to call the reference before? Don't feel like we did. But anyways. Yeah, and that's just, those were based on the parent. This is absolute. Matrices. For more advanced users. It might not be me right now. Okay. That is definitely useful. And I'm sure there's ways to use it usefully, but I am not Gonna mess with matrices right now. I'll tell you that much for free. Oh, layouts. Layouts allowed. Okay. Been working with layouts so far, but apparently now we're going to learn about them. We flex our boxes. Any more node extending layout can become part of the layout. Just includes but not limited to a rect circle image. Sure. Got it. Layouts are an opt-in feature, meaning they need to be enabled. So I'm saying layout property in the node that we want to become a layout. Oh, okay. So instead of layout being like its own thing, really? Oh my god. Of course, it can't be that simple. Just setting the layout property doesn't always turn into the layout node root. If the node is already a part of the layout, it will be treated like the rest of the descendants. So, we can't layout in a layout. Got it. Give me some examples, please. Okay, so this is working. Cool, cool. And what are we looking at? Cardinal directions. Okay. So right now we have a rect that's not a layout. We have a rect that's not a layout. And we have a rect that's not a layout. And none of these are layouts, so I don't know why. Why did we learn about layouts? Okay, so just skipping this part, I guess. Am I missing something? Is there some layout here? No. Okay, so we get no example for how these layouts work, but that's fine, I guess. So in this example, we use place two squares on the left and right side of a gray rectangle. The yellow square's position. Okay. So, let's see. This first rect that we have a reference to is this gray one in the middle here. Yeah. Let's just change it to be more red. Yeah. Okay. So we have a reference to this middle gray rectangle. This rectangle, we say, shares its rotation with this one, and its right side is the left side of this. And if we change it to top, as it suggests, it's not quite the top I would have expected. Again, interesting. The rotations match, but the top is... Huh. Try changing right to... Well, it's not. Okay, that's why. Because the right side is butting up against the center. If there was like a little... If you imagine a little dot dead center on the top here, and we change this to top, the little dead center of the right is on the little dead center of the top. That makes sense. Okay. And if we said the bottom... we can spell. Yes, got it. Okay, that's cool. So these things are linked in that way, and I'm assuming the big reveal at the end is that we're just rotating the gray one and everything else is following. Yeah, that is the big reveal at the end. Okay, and then this one has to maintain a constant rotation, but its bottom left point also has to stay on the bottom right of this rectangle. And if we said top left, just to be weird. That's a cool looking little image right there. Alright. Okay, and then we're just rotating the middle one, and everything else is figuring itself out. Very cool. Okay, see, this is where the power of this thing starts to come in. Because up till now, we've just been moving, squares around. Okay. Most Flexbox attribute available in CSS are available in layout properties. You can check out the yada yada. Everybody loves the Flexbox. Okay. Okay. For some reason we didn't get to have this one as a dynamic one, but sure. From layout specs to all example bar setting. Nodes that don't extend the layout class, such as the node itself, are unaffected by the layout and are treated as if they were never there. It seems like a weird way of describing what I'm seeing here. But okay. I don't understand this layout keyword because it doesn't seem necessary unless I'm fully confused, which is more than possible. Because we come over here and say I also want to use a layout. And I also want to use a node. Thank you. And I also don't need to do that. And I also need to zoom out. Okay. So if I take the layout keyword away from here, it goes away. And if I bring it back, it goes back. Okay. Sure. I don't really understand that. And the things we had before didn't have that layout keyword, so also didn't seem to matter. But I get this part. You are putting them inside of another node, and all of the things here trickle down. So I bet if we said, like, the width here is 100. No. Oh, because it's already set up here. And we can't overload it. Maybe not? That's pretty strange. Can I change the fill? No, fill is also not an attribute of the node. I guess nodes don't have a huge number of attributes like the things underneath them do. Which makes me question if this is even useful, but alright. Now we move on to the signals. Okay. These represent a value that may change over time. They can be used to define dependency between the state of an animation. This way, when a value changes, it'll get automatically updated. Okay. Alright. That makes sense, because there's many ways to link things together, and I guess this is one of them. So we create a signal. And there's also a vector 2 signal, which we saw before, but they didn't describe yet, but they used, so. Alright. Oh, interesting. We also have a signal for things like the fill color of this circle. So they can be invoked to perform 3 actions. We can get it, we can set it, and we can tweet it. Okay, so this doesn't seem... I mean, it doesn't seem different than stuff we've seen so far. Okay, so we can create a signal for the radius. We can create a signal from the radius. And then they update. They're linked. Sure. I would love to mess with this in an example. Why do you not have an example for this? Okay. Let's just, I want to just have a, I want to go back to like the first page, but I also don't want to lose everything. Let's get started. Let's come here. Let's come quick start. Let's take this, put it back, get our cool little bouncing ball. Don't really care about the ball. do care about copying this to a lot of anger in that one. Why can't I have a second circle? What's it telling me? Expected one. Oh, because this all has to be inside of a layout, I guess. Strange. Let me put these both in a layout. Okay, now they're both there. One doesn't change, one does. Cool. Cool, cool, cool. Now let's try coming back and talking about our signals. Const. Let's just do the radius like they were talking about. Radius equals a signal of 5. No, it doesn't. Because of course it's create signal. Okay, it's not just signal like the reference says right here. Oh, sorry, that does say to retrieve it. I'm getting ahead of myself. That's on me. That's on me. Create a signal, which we then, oh, and it imported itself. How nice. And now, does this have a radius property? No, it does not, but that's okay because these will just be the same for the radius. That number is going to be so small. There we go. Okay. And if I say the const rad2 is equal to create a signal of radius times 2, we're retrieving it, yeah? Okay. Okay, and now if we take our rad2, and we take we put it there, and we put it there, now we should have one that's double the size. Now, that's all fine and good. I believe now, what we should be, let me minus this to 500. Sure, it goes off screen about whatever. I believe what we should be able to do now is we should be able to say on my circle dot size 2, 2, 1. Yeah? No. So close. What am I missing here? My circle dot size dot x 100, 1 now. Oh, well, don't put that there. Got it. Okay, hold on. Radius dot. Oh, sorry, just radius 100, 1. Choo, I really thought that would do it. Well, it seems it does and it doesn't. Argument of type void is dun-ba-da. If I set the 1, it doesn't, it's not tweening it, which is strange to me, because I feel like if I hit play, maybe that would work. Okay. Alright. Here we go. So now, so this is, okay. Now I do feel like this is powerful, but not quite what I'm going for. I think I'm going for my circle dot size is gonna be 200 comma 200 comma 3 play. Now that's unfortunate. I was imagining that this sort of backwards propagates. That is, that when I set this, because it was set from this radius signal, that signal will then propagate to this rad2, which is based off the same thing. And it doesn't. It does, however, probably make sense, do that, which allows there we go. Did I have it? Okay, it was 500, so yeah, that wouldn't change much. Go down. Yeah. So those two things are now linked. Okay. Okay. Laziness. That's me. Signals always calculate area calculation. Okay. That makes sense. So it's not. Alright. Once it's calculated, it's saved and returned. Dun. The area signal keeps track of the other signals it depends on. Okay. We change radius signal, the area signal is notified about that, but it doesn't get recalculated immediately. It's still at play. We can do it as much as we want. So it's only once everything updates that there's anything to worry about. Okay. See, am I almost at the bottom of this page? Yes. Okay. So I'm going to get to the bottom of this page, and that's where I'm going to call this stream, I do believe. But signals keep track of the initial values specified during creation. At any time, we can reset a signal to a default symbol. Oh, interesting. So it saves whatever it was, and you can reset that. We can also use the default for tweening. Sure. Okay, and that can make a nice smooth animation here. We'll say radius with default over a second, and now it should, yeah, that's just going up and down. The value doesn't jump back at the beginning. Resetting default is useful. We set the line height of the text node to 150%, so override it, which would be inherited. Okay. I'm so confused what this is trying to tell me. We set the line height of the text to 150%, so we'll override its default value, which would be inherited from the parent. Alright, got my curiosity. Yeesh. No, I don't want a TX, I want a TXT. Is it black text, I guess? Oh, I know what the problem is. 255. There we go. Okay, and it was black text. Okay. So, and supposedly this will change the size? No. I don't understand what this is trying to tell me. Because if I do text dot line height 200%, probably in quotes would make sense there. Except I can't. It's not assignable. Is it because the percent comes at the end? Yes, strange. So if I take this away, nothing happens, and if I put this back, nothing happens. Is this just a terrible example because line height doesn't exist if there's no new line? What is this trying to tell me? Okay, this one looks cool. I believe this is gonna be, yeah. So, whoops. No, I don't want to, bleh. There we go, that's what I was looking for. So now, yes. So this is doing all kinds of maths and such. We create a signal from the radius, the area is based off of that, and then we can come down here and we yield on the radius and we wait. And everything is very synced up. Okay, cool. Well, I feel like we're just starting to get into usefulness, unfortunately, but I do need to stop there. So this is cool. I'm looking forward to continuing to learn about this stuff. We were on signals here. All right. Yeah. All right. Well, that's everything. End of the stream here. Hope you guys have a good rest of your night, because it's probably late wherever you are. It's late where I am. And I'll see you next time.